Welcome to Spring LIB.
For this question, we have light with a wavelength lambda equal to 589 times 10 to the minus 9 meters, or 589 nanometers, and it falls on a diffraction grating, and it has a diffraction angle, theta 1, of 16.5 degrees. I call this theta 1 because this is the first order where m is equal to 1. It wants to know how far apart the slits are and at what angle will the third order be observed. So the first thing we need to do is figure out the distance between the slits. This is because the equation is d times the sine of the angle theta is equal to m lambda. So if we can find d and we know m and lambda, then we can solve for theta. So the first thing we're going to do is solve for d, because at m equals 1, we know everything in this equation. So d then would be equal to 1 times lambda, which is just lambda, divided by the sine of the angle of the first maximum, which is theta 1, as written above. So plugging those values into this expression, we find the distance between the slits is 2.07 times 10 to the minus 6 meters, which we can box in as one part of our solution. Now that we know that, we can find the angle when m is equal to 3. So we'll start a new page for this, but what we have here is that, again, using this equation here that I'm pointing to with the arrow, we can solve for when m is equal to 3. We have theta 3 is equal to the inverse sine. We have to take the inverse sine of both sides to isolate the angle. So it'd be the inverse sine of m lambda, where m is equal to 3. So this is 3 times lambda divided by d. So we know d since we just solved for it. So plugging those values in and taking the inverse sine of that ratio, we find that this is equal to 58.6 degrees, which we can box in as the second part of our solution to this question.